to the first tutorial in a two-part series on the topic of statistics. Now, statistics is a huge sort of offshoot of mathematics, and it's used in so many different ways, and it affects our lives in many different ways because the powers that be either use statistics to talk to us, to convince us of certain things, or they use statistics to try and figure out the right way to go about certain problems, like the economy or the health service and so on and so forth. So the world around us these days is so complicated in so many different aspects that we can't always describe it in detail in a way that's helpful. And so we want to have kind of tools that can give us an insight into what's going on. And statistics is one of those tools that can really condense a lot of confusing data into a few numbers. So typically you might want to know something like, well, what's the typical value of something and how much does it vary by? And so a lot of statistics really tries to answer that question, that given some data, what's an average in sort of loose language, and what's the variation around that average. So in this level of maths, particularly in the Scottish curriculum, and probably similar in other curricula, I think it's very positive that they do test two very different ways of calculating a sort of an average or a typical, and the variation around that. And I'm sort of putting quotation marks around all these terms because in statistics there are much tighter definitions of all of these things, but I'm just trying to give you a sense of it right now. It's good that you have a basic knowledge of statistics because I think you need to be able to always be on the defensive if someone's giving statistics to you to try and convince you of something. There's a famous phrase, lies, damned lies, and statistics, meaning that the worst sort of limit of deceit lies in statistics, and I'm afraid there is some truth to that these tools can be used to befog the listener or the viewer, and one always has to be on one's guard. With someone trying to convince you of something only using statistics. That said, they are very useful if used in the right way and used honestly and conservatively, I would say. However, you're not here to listen to my opinions, you're here to learn some statistics, so let's get cracking. The two methods, be one method in this tutorial and the other method in the subsequent tutorial. The two different methods, one is calculating what's called median and quartiles, and we'll do that method in this first tutorial. And the second method, we're going to be calculating something called the mean and the standard deviation. The underlying idea is identical in both cases, though. We're trying to get a number that gives us a sense of the average or typical, loosely speaking. And we're trying to get a number that gives us some idea of the variation about that average. And I'm going to try and use the same data set actually for both methods so that you can actually compare them. So let's imagine, I've got my data actually written down here, sort of pre-prepared. So let's imagine then that we are just counting how many hours of sunshine there are. This is clearly somewhere with a fairly high latitude because the numbers do vary somewhat, so we're probably getting some Atlantic storm systems coming over. But on subsequent days, these are the numbers of hours of sunshine that were recorded. So on day 1, there were 5 hours of sunshine. On day 2, there were 6 hours of sunshine. On day 3, none. I used to live somewhere that was like that, I'm not saying where, but it was cloudy every day, all day. It was quite depressing. Day 4, 2 hours. Day 5, 6. And it seems they came in for a sunny spell, because then they had 7 hours and 8 hours of sunshine. That's really quite good. But then a cloudy day, but then back to sunshine again for the last 2 days. So that's some data, okay? I'm saying that it's hours of sunshine recorded on 10 successive days at some location. And you might be given that data and asked, what's the average number of hours of sunshine in that place this time of year? What kind of variability is there? Alternatively, I'm just thinking this could be the number of pups born or number of kittens born to some pet, in 10 different households, something like that. So these numbers could represent 100 different kinds of data. Let's stick with our hours of sunshine just for a point of contact. Now, the first method then, we're going to talk about median. This is the quantity that's going to give us a sense of, kind of the average. Let's deal with that first, and then we're going to talk about the variability, talking about something called quartiles. Now, the first thing you have to do if you want to calculate the median with a data set is to order it in terms of size. So let me just try and do that here. So I'm going to order the data. So the smallest number is 0, and then I have 1, and then I have 2, and then it jumps to 5, and then I have 6, 6, 7, 7, 8, 8. So I've ordered my data. Now, once you've ordered your data, the definition of the median is that it's the middle value of your data. Namely, half of the data lies below the median and half of the data lies above the median. Now, we have an even number of data points here. We actually have 10 data points. If you have an even number of data points, to calculate the median, you actually just take the middle 2 values and you take their average. So these could have been different values. In our case, they're the same, but in either case, you would take the average of the middle 2 values. Obviously, if they're the same number, then you're just going to get that number as the average. Okay, that's the median. So for our data set, the median is equal to 6. Let's just imagine that we didn't collect that last day of data. I just want to do that as a comparison. So let's just say, I'll put this in curly brackets, let's just say we had a 9-day data set. Okay, so this is for 10 days here. The reason I want to do this is to show you how to calculate the median if you have an odd number of days. So 9-day data set would be all bar the 7. So when I order the numbers now, I don't have one of the 7s in there. Okay, that's the 9-day data set. And the middle value here, because there's an odd number of points, you can just uniquely see what the middle value is. That would be the median. All right. In this particular data set, it has the same numerical value, but just to show you the two different methods. Even number of points, once they're ordered, take the 2 middle ones and take the average. Odd number of points, just take the middle value, which will be unique, and that's your median. So that's already giving us a sense then that the kind of, formally speaking, the median, but we might say the kind of average, middle of the range value of days of sunshine at that place is 6 hours. But how reliable is that? How much variation is there about that? We can get that by looking at different quantities. Now, a very crude way of doing that is to talk about the range of the data And that literally is the largest value, take away the smallest value. So the range of the data here is 8 hours of sunshine. That's actually quite crude though. Some data sets have what are called outliers, where you get an extreme value, and if you only talk about the range as the greatest value minus the smallest value, that's really not helpful at all. So a slightly more sort of intelligent way to talk about the variability is to talk about quartiles. And this is quite a nice method to sort of get into the data. So let's call them Q1, Q2 and Q3. Now Q2 actually is our median already. So we've already calculated the second quartile. These quartiles break the data set literally up into quarters, and the second quartile separates the lower 2 quarters from the upper 2 quarters, so it is literally the median as we've defined it. The first quartile is the median of the lower half of the data. Now, sorry to be confusing here, but there are different definitions of how to calculate these quartiles. So I'm going to use the one that the Scottish Exam Board uses. Okay. So for the Scottish Exam Board, if you have an odd number of data points, okay, then the way that you calculate the quartiles is as follows. If you have an odd number of points, the median is the central value, and then you do not include that value in calculating the first and the third quartiles. You would take the lower half of the data without that median value, and you would take the median of these numbers to get your first quartile. Likewise, you would take the upper half of data, excluding the median, to calculate your third quartile. So the first quartile then, if you had an odd number of data points, is the median of these 4 points. Now we have an even number of points, so we have to take the average of the middle 2, and we would have 1.5 as the average there. That would be Q1. And for this upper half, again we have an even number of points. We take the average of the middle 2, and that gives 7.5. That would be Q3. And as I say, the median is literally Q2. Now there are other definitions, and I'm sure that there are pros and cons to these. Other methods, you include the median in the lower half, and then you include the median in the upper half. But let's not go into that. At least for the Scottish Exam Board, you exclude the median if you have an odd number of data points in calculating Q1 and Q3. If you have an even number of data points, there's no real argument, because there's a very natural way to do this. The median is awkward because you have to take the average of the middle 2 values, but then you, with an even number of data points, have an easy split between a lower half and an upper half, and the Q1, the first quartile, would be the median of the lower half, which is the median of this set of data. That's the lower half. And Q3 is the median of the upper half of data, which is that set there. So these are quite straightforward, right? So Q1 then is the median of this data set. There's an odd number of points. The median would be the middle one, which is equal to 2. And the median of the upper half of data, there are again an odd number of points. The median is the middle one, be Q3 there. So I'm not going to talk about this 9-day data set anymore. I just wanted to have it there in the wings because of this awkwardness in defining median and quartiles, whether you have even or odd numbers of points in your data set. Going back to our example, we have an even number of points. We've calculated the median, and then we can read off Q1 and Q3. So Q1 in this case is 2 hours and Q3 in this case is 7 hours. And then we have something called the interquartile range, which is meant to be, and I think it is, a more meaningful measure of variability compared to the range, which, as I say, would include real outliers and could be quite deceptive. So the interquartile range, is just defined to be Q3 take away Q1. Let me call this IQR because it's quite a lot of writing. So the interquartile range is just defined to be the third quartile take away the first. So for us is 7 take away 2 is 5 hours. And then we can also talk about the semi-interquartile range. And that would be just half of the interquartile range. And this tends to be the thing that you're asked to calculate, is the semi-interquartile range, which in a way is the analogue of the standard deviation in terms of what's asked for variability. And as I say, we'll be talking about standard deviation in the next tutorial. So in this case then it's 2.5 hours. So I think with this data set, using this method, I think a kind of a meaningful statistical statement would be we measured the number of hours of sunshine per day for 10 successive days. We found that the median number of hours of sunshine was 6, and the semi-interquartile range was 2.5 hours. And so very crudely, you could say that in that location at that time of year, you would have statistically something like 6 plus or minus 2.5 hours of sunshine, giving you a sense of the kind of the middle value and the variation. Right, okay. So that's one method. I'm just thinking when I said 6 plus or minus 2.5, how poorly that actually does reflect this data. It doesn't take into account really that we never had more than 8 hours of sunshine, and we did have these very low values. So I think, kind of amusingly at the end of doing this analysis, which is a fine analysis, we do see that statistics is quite a crude tool when really trying to explain real world data, because of things like weather having extreme variability. How do you really talk about having days with zero sunshine in a statistical sense without going into quite a lot of detail? But there it is. So I hope, more to the point, that this method has been shown to be clear to you. The awkwardness with median and quartiles is this messing around when you have either odd or even number of points in the data set, and some ambiguity with an odd number of points of how you define your quartiles, which, is a bit icky. The advantage of the next method we're going to talk about is that it doesn't care about how many data points you have at all. It's just a brute force method, and much easier in that sense to apply. A little bit more awkward though in terms of the in terms of the calculation. So that's that, and I'll see you for the next tutorial in statistics. Bye for now.